Hi everyone and welcome back. In this video I'm going to be talking about some composite forms in which we're combining rectangular prisms with cylinders. Okay, so now we are combining the two forms that we've been talking about. So in this first example, just start by showing you the picture here. So we have just a basic rectangular prism. However, it's got a cylindrical tunnel or hole cut straight through it. So that means on top of the surface area of the rectangular prism, we also have this little curved cylindrical tunnel through the center that we'll have to calculate as well. So you can see that I've already broken it down to outside plus inside. Okay, as soon as you see you have a tunnel shape, you know you're going to have to do an outside calculation and an inside calculation. Alright, so because I am dealing with a basic rectangular prism, aside from that hole there, I can break it down into my matching sets of sides. So I've got front slash back, plus left slash right, plus top slash bottom. Okay. The inside, as you can see, if I imagine making a cut down that cylinder and laying it flat, I would just end up with a great big long rectangle. And area of a rectangle is just simply length times width. Or in this case, the length of the cylinder, which is the same depth right here. So it shows us that the depth of this is 3 centimeters and this runs all the way through. So that means that it's 3 meters long. Times my width, that's the part that wraps around the circle. So in other words, that's my circumference, pi times d. Okay. Going back over here, looking at my outside calculations. So you can see whatever I do to get the front, I double to account for the back. Whatever I do to get the right side, I double to account for the left side. And whatever I do to get the area of the top, I double to also get the area of the bottom. So when it comes to the front face, which you can see I've color coded in green, so yes, it's just a basic rectangle, length times width, so 8 times 12. However, I've got this circular hole missing from it. So I have to deduct or subtract that area. Formula for finding the area of a circle is pi r squared. So you can see I've got the length times the width minus pi r squared, minus the area of that missing circle. When it comes to the other faces, left, right, top, bottom, there's nothing missing. So they're just simple rectangles, length times width, length times width. So that's a lot easier there. Nothing much to worry about with those ones. So with my front and my back, I've got 8 times 12, my length times my width, minus 3.14, my approximation for pi, times my radius squared. How did I get a radius of 2? Well, if I look at the circle, it shows me that the diameter is 4, and I can easily get from diameter to radius by just simply splitting it in half. So you can see right here I did 4 divided by 2 gives me 2. So that number right there is my radius. Okay, that calculation right there was for my radius. So that's how I ended up with 2 squared. Okay, so keep going. 8 times 12 is 96. 3.14 times 2 squared is 12.56. Subtract those two numbers. 96 minus 12.56 gives me 83.44. And then last step, that is the area of this front face that I can see, but the back that I can't see is matching. So that means I can just simply double it to also account for the back. So there is the total for my front and back, 166.88. Okay, left and right. Like I said, I just get to do a simple length times width calculation. 3 times this right here is in line with this, so 3 times 8 gives me 24, and then double it to also account for the other side, which brings me to 48 for left and right. Top and bottom, again, just a simple rectangle. Length, 12 times my width, 3. 12 times 3 gives me 36. And then I double it to also account for the bottom, which I cannot see under here, but that I know is identical because it's this symmetrical face. So 36 times 2 gives me a total of 72 for top and bottom. So that takes care of the outer calculations, the outside calculations. Now for the inside, like I said, because it's just a cylindrical tunnel, that means it's just a rolled up rectangle. Okay, so just like this is my rectangle right here, and I roll it up. Well, I've created a cylinder, right? So you make a cut, lay it flat, that's the rectangle I'm talking about. So if the depth of this rectangular prism from here to here is 3 centimeters, well, that means that the depth of this cylinder is also 3 meters. Sorry, I keep saying centimeters. 3 meters. So that's my length. And then my width, when I cut this flat, this was the part that was wrapped around the circle. That's my circumference. So pi times d gives me circumference. So 3 times pi times diameter. 3 times 3.14, that's my approximation for pi, times, and the diameter of the circle, well, it was given straight to me right here, 4 meters. So times 4. Put that in my calculator, press equals, and I get 37.68 for the surface area of that curved part on the inside. Final step, pull out my calculator, type in all of these numbers, 166.88 plus 48 plus 72 plus 37.68, and grand total, I got 324.56 meters squared. Okay, so that's what you do if you have a cylindrical tunnel cut into a rectangular prism. Okay, so the last composite form that we're going to look at that combines both a cylinder with a rectangular prism is this one right here, where you've got the cylinder attached on top of the rectangular prism. So this one, believe it or not, is actually quite a bit simpler than this tunnel question, and I'll show you why. So first of all, I'm going to start the same way here. As soon as I see that I'm dealing with rectangular prisms, I'm going to be breaking it down front, back, left, right, top, bottom. So that's the first thing I'm going to do. Front, back, plus left, right, plus top, bottom. Okay, so if I imagine looking straight on at this from the front, what would I see? Well, I would for sure see this front face of the rectangular prism. I would also see this. However, I cannot calculate this straight on because it is curved. So I can't be trying to calculate just the area that I see. That just doesn't work with cylinders. Okay, when it comes to cylinders, you have to visualize cutting it and laying it flat. So that I cannot cover with my front slash back view. So that means that this curved side, I will have to do as a separate calculation. So in a separate color, I'm going to put plus the curved side that wraps all the way around. So that is its own thing. I can't cover that in any single view because it wraps all the way around. So I'm just going to color code that with brown. Okay, so that means for my front view, that's just going to cover this, and then the back, which will be identical, I can't see, but I know is back there. Okay, so for the calculation of that, well, it's just simply a rectangle that I'm dealing with. So it will be 2, so that it covers front and back, times length times width. Okay, I'll fill in more detailed information in a second. I'm just going to start by getting my formula here. So my left side and my right side, so the right side I can see right here. So if I look straight on from the right, this is what I would see, is this rectangle right here. And of course, again, I would see some of the curve, but I cannot cover that whole curve from a single view. That's why we have it separated, so I don't even need to worry about that right now. So that means that it's just a rectangle that I'm dealing with. And of course, the left side I know is identical, so it's the symmetrical face there. So again, I'm just going to be doing 2 times the length times the width. And then finally, if I look down from the top, straight down from on top of this form, I will see this flat circle. Okay, if I'm looking straight down on it, it will just appear as a circle. And it will just be a part of this rectangle. So the beauty of this is that if I calculate the area of this rectangle, that automatically accounts for the circle face that's a part of it. So kind of just want to draw it for you here. I think I'm just going to draw it down here. So basically, if I looked straight down, I would see my rectangular face. It's actually close to a square. And I would see a circle as well. But what I'm saying is that I can cover that entire area with just my length times width calculations. Okay, just like that, that covers all of it. So I don't even have to worry about calculating the area of that circle. So that is actually the beauty of this composite form. So again, I can just do 2 times length times width. Okay, and then lastly, the last part of my formula here is the curved surface, which just like I said up here, if we were to make a cut and lay it flat, it would just make a big long rectangle, and the length of that rectangle would be the same as the length of the cylinder. That part doesn't change, so 2 centimeters. And then the width of that rectangle would be what wraps all the way around the circle. So in other words, the circumference. So anytime I'm trying to find one of these curved sides for a cylinder, it's always just length times pi times diameter. So that is the formula that I would use for this kind of form. So let's fill in the details. So front and back, 2 times, let's see, what are my dimensions? I've got 10 by 3. 10 times 3. Left, right, 2 times, what are my dimensions? 8 by 3. 8 times 3. And top and bottom, what are the dimensions of the rectangle? It would be, oops, so make sure I put my 2 down first. So 2 times 10 by 8. 10 times 8. Okay, so let's get our actual numbers here. So 10 times 3 gives me 30, and then 30 doubled, or 30 times 2, gives me 60. So that accounts for my front and my back. Okay, 8 times 3 gives me 24, and 24 doubled gives me 48. So that accounts for both my left and my right. And lastly, top, 10 times 8 gives me a total area of 80. So the area of all of this, including that circle there, is 80 centimeters squared. And then I know I have the identical face on the bottom that I can't see. So I just double 80. 80 times 2 gives me 160. So that accounts for both my top and my bottom. Okay, so then all that I have left is my curved side. So the length of my cylinder is 2 centimeters times pi. My approximation for pi is always 3.14, that never changes, times the diameter of the circle, which is given to me right above here, and it shows that it's 6 centimeters long. So times 6. Okay, if it had given me the radius instead, if it showed me that halfway from the edge to the halfway point was 3, then I would just double it, 3 times 2, and then I'd get to 6. Okay, which you sometimes will see. Not always will they give you exactly what you need in terms of radius diameter. It's important that you know how to get from one to the other. Okay, so then I can just multiply those. 2 times 3.14 times 6 equals 37.68 centimeters squared would be the area of that brown part that's wrapping all the way around the cylinder. Okay, so my final step then is just going to be to add up all of these faces. 60 plus 48 plus 160 plus 37.68 equals, so my grand total is 305.68. My original units were centimeters, and I'm talking about area, so it's centimeters squared. Box it up. Nice and neat. Final answer. Alright guys, that's it for this video, and that is it for this foldable. Thank you so much for watching, and I will see you in the next one.